Hi, it's me again. So for this video, we will be discussing continuity of a function. So sinasabi natin na yung isang function ay continuous at x equals a kapag yung graph ng function mo at a ay dumadaan without interruption. Meaning, yung graph ng f at a ay walang holes, walang jumps, walang gaps. So continuous no, yung pagdaan ng f at a. So halimbawa, let's look at this one. Halimbawa, meron kang function g na ganito yung graph. Then clearly, this g is not continuous at x equals a. Ayan no, since meron tayong jump at gap. What else can we say though, aside from being not continuous? Well, you can see that g of a does not exist. In this case, walang function value na naka-assign sa a. Moreover, pag chinek mo yung limit, tandaan no, hindi porket hindi nag-e-exist yung function value mo, wala ka ng limit doon. Pwedeng magkaroon ka pa rin ng limit kahit undefined yung function mo doon. But in this case, even the limit as x approaches a does not exist. Kasi yung limit as x approaches a from the left, papunta po sa point na to, sa 0, yung limit as x approaches a from the right naman, papunta dito sa kung ano man itong point na to. So the limit does not exist dahil magkaiba yung limit from the left and from the right. Ito naman, ganun din, hindi pa rin siya continuous at a, itong function na to, kasi nagkaroon tayo ng jump, hindi tuloy-tuloy. Pero, g of a exists this time. No? Ito siya, meron tayong function value assigned kay a, which is this one. But still, yung limit as x approaches a ay hindi nag-e-exist since magkaiba pa rin po yung limit from the left. Pupunta rito ay yung limit from the right. Itong function din na to, no, hindi rin ho siya continuous at x equals a dahil sa gap na ito. Okay? Tapos, wala rin tayo nakikitang function value dyan sa a. But this time, the limit exists as x approaches a. Limit from the left, papunta rito. Limit from the right, papunta rin dito. So yung limit as x approaches a ay itong b na to, whatever this b is. Okay? Last, dagdagan natin dito. Nabigyan natin ng function values a. But still, this function is not continuous at x equals a because of the jump. Tumalon siya doon. Papunta rito. Okay? But this time, g of a exists. We have assigned a function value of a for a, which is whatever this number is. The limit also exists. In this case, no, yung limit from the left and yung limit from the right ay papunta sa b. However, what you can notice is that yung limit from the left and yung limit as x approaches a, magkaiba doon sa function value ni a. Okay? So from this, we will be able to form a criteria kung kailan natin masasabi no, na f ay, ng isang function f ay continuous at a real number a. At that happens if three conditions are satisfied. Una, kailangan yung function value at a nag-e-exist. Pangalawa, yung limit as x approaches a nag-e-exist. At pangatlo, kailangan mag-equal yung limit na yun doon sa function value. So this is an easier criteria to check whether your function is continuous at a instead of graphing your function. So you have three necessary conditions no para maging continuous at x equals a. So kahit isa lang dyan ang mag-fail, no, then you can already say that f is discontinuous at a kahit isa lang sa tatlo na yan. And then we say that f is continuous on the interval ab kapag po siya ay continuous sa bawat number sa interval na yan. Okay? So, let's look at this example. So, we want to know if this function, f of x, is continuous at x equals -2. Well, you could graph it if you want, but we could agree that that is a very hard thing to do. So, we will check for the three conditions instead. So una, ano nga po yung una? Function value. Does f of excuse me, f of -2 exist? Let's check. We can just plug in x or negative 2 to the x, and you can see that you'll get a function value of negative 6. So first condition is satisfied. F of negative 2 exists. Specifically, f of negative 2 is negative 6. Is condition 2 satisfied? Is the limit of this polynomial function existing as x approaches negative 2? Well, yes. It's just a polynomial function. So to get the limit, you just plug in negative 2, you get negative 6. Second condition is satisfied. Moreover, itong function value at ito pong limit ay nag-equal. So third condition is satisfied. All of the conditions are satisfied. F is continuous at x equals negative 2. Okay? How about this one? Is this function continuous at x equals 6? Let's check. First condition. Let's check if f of 6 exists. If you try to plug in 6 to all the x's there, yung taas, you get 36 minus 18 minus 18, that's 0. But yung baba, you also get 0. Undefined. Does not exist. Tapos ka na. One condition already failed. You can already say f of x is not continuous at x equals 6. So again, tapos na tayo. Alam na natin hindi siya continuous. But check lang natin, no, ano kaya mangyayari if we check for the second condition. Yung limit, check lang natin, no? So, limit as x approaches 6 of this function, sabi natin kanina, pag sinubukan mo i-plug in si 6, you'll get 0 over 0. But we can simplify this function like this. Yung taas po ay factorable as x minus 6 times x plus 3. So, x minus 6 can cancel. I have here x plus 3 na matitira. Pag pinasok ko si 6, I get 9. So, second case is satisfied. Pero again, hindi siya continuous because first case fails. Okay? Good. Subukan naman natin tignan itong greatest integer function mo. Is this one continuous at x equals 3? Well, function value clearly exists. If you plug in 3, magkakaroon ka lang ng GIF ng 4, which is 4. So, okay tayo sa first. Second, does the limit exist? But, to check the limit as x approaches 3 of this function, this is a greatest integer function. And when you try to plug in 3, the inside becomes an integer. So, in this case, we have to consider one-sided limits to know the limit as x approaches 3. Limit from the left, if you try to plug in values of x less than 3 here, halimbawa 2.99, you'll get GIF ng 3.99, that is 3. Kapag naman kinuha mo yung limit as x approaches 3 from the right, if you try to plug in values of x close to 3 from the right, let's say 3.01, you'll get GIF ng 4.01, that is 4. So, ano masabi mo, limit from the left and from the right, magkaiba. So, the limit of this function does not exist. So, second condition fails. We can stop right here and say that g is not continuous at x equals 3. Okay? So, before we continue, let's have some quick facts. No? Una sa lahat, very useful, polynomial functions are continuous everywhere. Yung number 1 kanina, in an example ng isang polynomial functions, and similar types of functions, no, they are continuous at any x, at any real number. Hindi mo na kailangan i-check. Rational functions, on the other hand, are continuous on its domain. Sabihin, continuous siya sa isang number as long as defined yung rational function mo dun. So, ibig sabihin, kung yung x na yon hindi niya pinapa-zero yung denominator, then your rational function is continuous at that x. And lastly, trigonometric functions are continuous on its domain. So yung mga sine, cosine, tangent, those are continuous sa lahat ng real numbers na nag-e-exist yung functions na yan. Okay? So now we will discuss the types of discontinuity. of a function. So, kunwari, meron kang function f na discontinuous at x equals a. Then you say that f has a removable discontinuity at x equals a if the limit as x approaches a exists. Ibig sabihin, yung second condition ay satisfied. Maybe nag-fail siya sa first or sa third. Basta alam mong discontinuous siya, but not because of the second condition. So kapag yung limit nag-exist despite being discontinuous, that is a removable discontinuity. Otherwise, kung hindi nag-exist yung limit, you say it's an essential discontinuity. And this includes po yung mga limit na infinity. Again, yung mga limits na infinity, those are limits that doesn't exist. No? So there you go. So itong essential discontinuity, mayroon pa siyang subcategories. Jump essential siya kapag, well, nag-exist naman yung limit from the right and from the left, kaya lang magkaiba. So that's a jump essential discontinuity. Kapag infinite essential, one of your one-sided limits approaches either positive or negative infinity. Okay? Okay, good. Now, if you have a removable discontinuity at x equals a, kaya siya tinawag na removable, no? Kasi you can redefine your function na mawawala yung discontinuity at x equals a. No? You can redefine it such that mawawala yung discontinuity, magiging continuous siya bigla sa a. Hence the term removable discontinuity. So how do we redefine a function na merong removable discontinuity? Well, you can define it like this. We retain the function value for all other x's except ibubukod lang natin ng definition si x equals a at ang ipapalit natin yung limit na na-compute natin. Pag sinubukan mo i-compute, ito pong function na to magiging continuous na at x equals a na wala na yung discontinuity. Okay? So halimbawa, yung mga example ng essential discontinuity ay yung katulad sa first two graphs na pinakita ko. Yan, dyan nangyayari yung essential. Yung removable naman dun sa sa third tsaka sa fourth graphs. No? And then dun sa mga examples natin kanina, halimbawa itong number 3, ito yung na-compute natin kanina. No? Nag-exist yung function value pero hindi nag-exist yung limit, but yung limit from the left and from the right, parehong nag-exist, hindi nga lang equal. So, hindi siya continuous. Moreover, you have a jump essential discontinuity. Limit from the left, limit from the right exist, but not equal. Yung second example natin, ito yung lumabas sa computations natin. No, kaya ako rin siguro kinompute yung number 2 even after knowing na hindi na siya continuous after first condition is because I want to know what type of discontinuity this has. And if you see the limit exist, no, despite being discontinuous, hence, you have a removable discontinuity. Tapos dahil siya ay removable discontinuity at x equals 6, we can redefine it to be continuous at 6 this way. Ito pa rin yung function, no? We still maintain it, but this is only now the function defined for x not equal to 6, and for x equals 6, binukod natin siya ng definition to be 9. So, yun na-compute mo kasing limit dito. Ay 9. Okay? Good. Now, for the rest of this discussion, we will focus on discussing the continuity of piecewise defined or your split functions. So first, we have to know what are your PPDs. No, PPDs or possible points of discontinuity, no, are your suspects kung saan pwedeng maging discontinuous ang isang piecewise function. So ano-ano yun? Mga possible points of discontinuity. Una, yung mga numbers kung saan nahahati yung domain ng iyong piecewise function. Those are some of your PPDs. Pangalawa, no? Real numbers kung saan undefined yung rational functions mo. Ibig sabihin kung saan ka makakita ng denominators na nasi-zero. And lastly, those that make the inside of your GIF integers. Those are also PPDs. So PPDs, these are your suspects for being kung saan pwede maging discontinuous ng isang piecewise function, but hindi po ibig sabihin na PPD ka na ay discontinuous ka na. Kung hindi ka PPD, then you're automatically continuous. No? Pero kung PPD ka, pwede ka pa rin maging discontinuous, pwede pa rin maging continuous. Okay? Game. Example. We have this piecewise defined function. Meron kang rational, GIF, tas polynomial defined in this domain. Sabi sa atin, discuss the continuity of this function at each PPD. So the first step is always to identify your PPDs first. Ano-ano nga po ulit yung mga PPDs? Una, kung saan nahahati yung domain ng piecewise mo. So in this case, this is divided by 1 and by 2. So those are automatic PPDs. Next, do we have rational functions here? Yes, this one. Is it undefined somewhere? Yes, at x equals -3, your denominator is 0. Pero check mo muna, no? Is x equals -3 in this domain? Kasi yung rational function na to para lang sa x less than 1. But when -3 is in this part of your domain, it's less than 1. So it's counted as a PPD. Etong GIF, well, ang domain, pasok lang naman siya sa x between 1 and 2. Diyan sa interval na yan, ang nagpapa-integer lang naman sa kanya is yung 1 and yung 2. Counted na siya dito. Okay? So we're done. These are your PPDs for this function. Now we will discuss the continuity at each of this one. So yung ginagawa natin kanina pa, gagawin lang natin sa bawat isa sa kanila to identify if g of x is continuous or discontinuous at each of these points. Una, at x equals 1, again, how do we check continuity? Function value, first condition. Does g of 1 exist? We will plug in 1 where? Here in the second one, because this is where x equals 1 falls. So g of 1 is the GIF of 1 minus 1. Dito ko siya pinug in. I get GIF of 0 or 0. So g of 1 exists. First condition is satisfied. Next, I want to know the limit as x approaches 1. 1 is a breaking point of your piecewise function. So to get the limit as x approaches 1, I have to consider one-sided limit since magkaiba yung function from the left and from the right. Okay. Limit as x approaches 1 from the left of g of x, ang gagamitin ko pong function ay yung function sa kaliwa ni 1, which is this one. Then I can just plug in 1. Wala naman tayong magiging problema to get the limit of this. I get 1 minus 1 minus 12 over 1 plus 3. I get -3. Yung taas kasi magiging -12. Yung baba 4, kaya -3. Next, limit as x approaches 1 from the right. To get that limit, I will use this function instead. Kasi po, iyan yung function defined sa kanan ni 1. Okay? But if I try to plug in values of x close to 1 from the right, say 1.01, then I have GIF ng 0.01. That is 0. So both of them exist, but ano sabi mo? Magkaiba yung limit from the left and from the right. Therefore, your limit as x approaches 1 does not exist. So hindi po siya continuous at x equals 1, and specifically, you have a jump essential discontinuity at x equals 1. Okay, good. Next PPD is x equals 2. Let's check. Does g of 2 exist? Where does x equals 2 fall? Dito, no? Sa third function. X squared minus 4 ko siya ipa-plug in, so I get 2 squared minus 4. That is 0. Okay, first condition, good. Nag-exist ang function value. Does the limit exist though? Let's see. Again, 2 is a breaking point of your piecewise function. So I have to check limits from the left and from the right. Limit from the left, as x approaches 2 ng g of x, I will use this one, the second function, since doon po define si x less than 2. So, ayan. But if I try to get this limit, if I try to plug in, say, 1.99, I get GIF ng 0.99, that's 0. Now, limit from the right of 2, I will use x squared minus 4 this time. So, pag kinuha ko yung limit na yan, I can just simply plug in. That's just a polynomial. It's 0. So, limit from the left and from the right nag-exist. Tapos, nag-equal pa. So, you compute your limit as x approaches 2 to be 0. Second condition is satisfied. Moreover, yung function value at yung limit parehong 0, nag-equal sila. Third condition is satisfied. Therefore, G is actually continuous at x equals 2. So, ito yung example ng PPD siya. No? It's a suspect for being a discontinuity, pero inosente siya. It turns out G is continuous at x equals 2. Anyway. Last PPD for this given, ang nakuha natin ay -3. Let's see. G of -3, no, falls here sa pinakaunang function. If you try to plug in, I get this. This is -9 minus 3 minus 12. That is 0 over 0. Sorry, this should be inside parentheses. Ayusin lang natin. Yan. Para 9. Sorry. Ito pala ay plus 3. Minus -3. So that's plus 3. Okay? Yeah. Okay. So, you get 0 over 0. Well, ang point naman natin dyan ay undefined, no? Yung function value at x equals -3. Okay? Good. Next. Check natin yun. Alam na natin na hindi continuous at x equals -3. But itutuloy natin sa second condition just because I wanna know what the type of discontinuity is. No, kung siya ba ay removable, essential. Let's see. In getting the limit of your function as x approaches -3, I don't have to consider left and right hand limits kasi ito lang naman for x equals -3, no? So, but if I check this limit, I get 0 over 0, sabi nga natin kanina, I can factor it like this. I can cancel x plus 3 sa taas, tsaka sa baba, matitira sa akin x minus 4. If I plug in -3, I get -7. So, second condition is satisfied, although hindi na siya continuous. Hence, meron po tayong removable discontinuity at x equals 3. Okay? Tapos, subukan natin i-redefine since meron tayong removable discontinuity, x equals -3. Again, the function will remain the same for all of the x's except at -3. So, dito sa unang condition natin, yung -3, inalis ko lang. No? X less than 1 except -3. The rest are the same. And then for -3, I have this one. Ang nilagay ko po, yung limit na na-compute ko, which is -7. Okay? So that's how you discuss the continuity of a piecewise defined function. Okay? Last example. Ganun pa rin, no? So discuss natin yung continuity of this function at each PPD. Tapos subukan din natin identify kung anong klase yung mga discontinuity na makikita natin. PPDs natin, -4, -2 automatic. Kasi po, breaking point ng piecewise function. Okay? Ito, tapos ano pa yung mga dapat i-check? Rational function. Itong sa taas, kailan 0 yung denominator? Kapag x equals -4. But that's already accounted for here. And besides, -4 is actually not in this domain. dito sa part na x less than negative 4. Si negative 4 hindi kasama dyan. So, wala tayong dapat problemahin dito sa una. Sa pangalawa, ito pong GIF ng 2x, kailan ito nagiging integer sa loob? Again, that's also part of your PPDs. Well, kapag sa interval na negative 4 to negative 2, nangyayari siya sa negative 4, sa negative 2, at saka sa negative 3. And then, itong third function, if you check, yung denominator can be factored like this. So, ano ibig sabihin yan? Meron pong dalawang number na nagpapa-zero sa denominator na to, negative 2 at negative 6. Yung negative 2, ayan na. Nabanggit na natin. No? Yung negative 6, do we include negative 6 in your PPD? No. Kasi, although it makes this undefined, negative 6 is not in this interval. No? Negative 6 is not greater than or equal to negative 2. So for this function, wala rin tayo i-consider. Ang naiwan lang kanina, hindi ko pa nalagay, itong negative 3 dito sa GIF. Okay? So these are your possible points of discontinuity. Let's try to discuss the continuity at each one. At x equals negative 4, function value ay negative 8. Okay? Again, ang ginamit natin, ito po, kasi po si x equals negative 4 ay nandito. So, if I plug in negative 4 sa second one, I get negative 8. Limit. Check natin yung limit niya. As x approaches negative 4. So, negative 4 is a breaking point of your piecewise function. So, I have to consider limits from the left and from the right. Yung from the left, alam na natin, ito yung gagamitin natin because for x less than negative 4, ito yung defined na function. Okay. So, ano mangyayari? If you try to plug in negative 4 here, I have 1 over 0 minus. 0 minus kasi as x approaches negative 4 from the left, if you try plugging in values less than negative 4, you get negative numbers here. Okay? So, ano pong sagot dito? Negative infinity. So, anong gagawin natin? Wala na. Does not exist na agad kasi one hand limit is infinity, tas therefore, alam mo na agad anong klase yan. Infinite essential discontinuity. Okay? Hindi mo na kailangan i-check yung limit from the right. Good. We're done here. Second PPD is negative 2. Again, first condition, function value exists, does not exist actually. If you try to plug in negative 2 here, no, sabi nga natin, pinapa-zero niya yung denominator dito. Kaya hindi po siya nag-exist. So, hindi na siya agad continuous at negative 2. But let's see, second condition, just to know what type of discontinuity we have. To check the limit, I have to consider limits from the left and from the right because negative 2 is a breaking point of your piecewise function. Limit from the left, I use this function, GIF ng 2x. And if you check, you'll get negative 5 as your limit. Next, limit from the right, I use this function instead. Sabi natin, if you try rather to plug in negative 2, yung baba, sabi natin, magsi-0. Yung taas, may x plus 2 ka dyan, so magsi-0 din yan. You get something 0 over 0, but we can factor out your denominator to something like this. Magka-cancel yung x plus 2, tsaka x plus 2, so I get negative 20 over x plus 6. Pag pinasok ko yung negative 2 sa baba, I get negative 20 over 4. I get, ito pala, negative 5. Okay? So, ano nangyari? Limit from the left and limit from the right, pareho pong negative 5. They are equal. Hence, the limit as x approaches negative 2 is negative 5. So second condition is satisfied. The limit exists. So removable discontinuity. Bago tayo mag-redefine, ituloy muna natin, no? Kasi baka mamaya yung natitira ay isa ring removable discontinuity. So, para isang redefine na lang tayo. Okay? Let's check the last one. At x equals -3, -3 falls here, no? So, to check the function value, I will use this one, and I get -6. Okay, good. Second condition, does the limit exist? To get the limit as x approaches -3, I only have one function to use, which is this one. Tama? But since it makes your GIF, the inside of your GIF an integer, I have to consider limits from the left and from the right using the same function lang naman na GIF ng 2x. Limit of next as x approaches -3 from the left ng 2x ay -7, and from the right you will get -6. Okay? So, magkaiba. Limit from the left, from the right, magkaiba, pero pareho namang nag-e-exist. Therefore, the limit does not exist, discontinuous, and specifically, jump essential discontinuity. So, are we done? Well, meron tayong naiwan task, no? Meron tayong isang removable discontinuity. So, redefine natin. Everything remains, that is at x equals -2, if you remember. So, everything remains the same. Ito kanina, x less than or equal to -2. Yung equal, inalis ko lang kasi nga i-redefine natin si -2 as -5, which is the limit you computed. Okay? So, that's it for this video. Yeah.